Okay, so again, let's look at this one. Now this thing has a mass of 2,567, right? Kilograms, right? And this thing has a mass of 1 kilogram, right? Okay, so essentially, basically the point of this one is that if it accelerates very, very slowly, that the tension in the cable is essentially, in this case, going to be the weight of this guy. But let's just solve this thing out, right? Guessing that positive acceleration is this way, right? And that positive is this way, right? The force down on this is 1 times 9.81, right? Right, so that's 9.81 newtons, right? And so for B, our formula looks like this. It looks like the tension is upward, the 9.81 is downward. Since down is positive, I go 9.81, the thing causing the acceleration, right? Minus the tension equals 1.00 times A. And then for A, okay, we have whatever that tension is, right? And that's the only force acting on it because there's no friction, right? So tension equals 2,567 A. And of course we can do what we always do. We just add the left side to the left side, right side to the right side, okay? So we end up with 9.81 minus T plus T, right? Which is just 9.81, right? Equals, and then this ends up being 2,568 A. Right, and now we can find the acceleration. It's going to be 9.81 divided by 2,568. And that is 0.00382 meters per second squared, and then we can find the tension by simply plugging into this formula, right? So tension is 2567A is 2567 times 0.00382. So I'm just simply going to go times 2567. Since 2567 is remarkably similar to 2568, of course we're going to get that the force is 9.80617, etc., right? Which essentially is 9.81 newtons. Okay, because the acceleration is so slow, the tension in that cable is essentially the weight of this, right? If you're accelerating down very, very, very slowly at a slow rate, right, the tension in the cable is significantly the same as the weight of the object hanging on the string. Okay?